Welcome to our screencast on exponents. For the opening, don't write these problems out. I'll let you know when you need to start writing in your notebook. I just want you to think about how you might evaluate these expressions. For instance, would you start with 4 and then add on 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 until you finished and got your answer? Maybe, but it's a little time consuming, right? Since this is repeated addition, you might also say, oh, well, we can use multiplication because multiplication is just repeated addition. So we could do 9 times 5 instead of adding. You could skip count. We could do 10, 20, 30, 40, 50. In this lesson, we'll be using exponents. So now you need to start writing. So these two sentences should be the very first two things in your notes after the title. Repeated addition helps us to learn multiplication, but repeated multiplication helps us to learn exponents. And that's something that you'll notice when we're working with exponents. There's actually no more addition signs. This was just to get us thinking about repeated addition. But in exponents, we'll only be using repeated multiplication. And that's one of the biggest mistakes that 6th graders make, is that they try to use addition with exponents and that just doesn't work. So make sure that you're using repeated multiplication. No adding. The first set of problems that we're working on will ask us to write the problems an exponential form, and let's highlight that too, exponential form. Do you see the word exponent in exponential form? That means they want to see this expression written as the base and the exponent. So I see the number 5 is being multiplied over and over again. 5 will be our base, and it's being multiplied 1, 2, 3, 4, 5 times. So in exponential form, this expression is written as 5 to the 5th power. For the next one, 2 times 2 times 2 times 2, the base is 2, and it's being multiplied 4 times. So we would read this as 2 to the 4th power. And you really want to make it clear the difference between your base and your exponent, because if you wrote them too closely to each other, it might look like this, and then you might just think 24. So your exponent has to be really tiny and up toward the top of your number, and that's actually called superscript, writing in superscript. So you don't want them to look like that. Your base numbers can also be decimals. So if we have 2 and 1/10 times 2 and 1/10, we can still write that in exponential form. That would be 2 and 1/10 to the 2nd power. And notice how I put the base in parentheses? That just makes it a little bit easier to understand what is being repeated as the factor. 75 hundredths is being repeated in this expression 1, 2, 3, 4 times. So here we'll do our parentheses, 75 hundredths to the 4th power. And then finally we have a fraction, 1/2 is being repeated 3 times. So we'll put that in parentheses as well, so that we can see what's the base and what's the exponent really clearly. That will also help when you have order of operations problems or PEMDAS problems where you have parentheses and exponents being used at the same time. Practicing the parentheses now will help you understand that later.